Hey everyone, welcome to question 3b of the 2017 Methods Exam 1. This question asks us to sketch the graph of f on the axis below and label all the axis intercepts and any stationary points with their coordinates. To make this a little bit easier, I've written f of x in its expanded form and in its factorized form, as well as the domain, which is -3 to 0. It's really crucial to remember this domain, because if you don't, you're certainly going to lose a few marks. Now the first thing I'm going to do here is that I'm going to notice there's x plus 2 whole squared in my function. This means there's a repeated root at x equals -2. This means that there's not only an intercept at -2, 0, but a turning point is also going to lie on that. Now the turning point could look like this, or the turning point could look like this. And we can just find out more about the shape once we start sketching the rest of the graph. Now the next thing I'm going to do is, I'm going to find my first endpoint. So I'm going to evaluate f of -3. So if I put this into my factorized version, I'll get -3 plus 2 whole squared multiplied by -3 minus 1. Now -3 plus 2, that's just -1. Whole square that, and multiply by -4. -1 whole squared is just 1, so this is just -4. So -3, -4, we're going to put that in. Next thing I'm going to do is find the other endpoint at x equals 0. For this, I'm going to use the expanded version, because it's just going to be much easier, and looking at it, you'll know that it's -4 as well. Because 0 cubed is 0, and 3 times 0 squared, also 0. So I'm going to put that in as well. Now the final thing that I really have to do here is find the derivative, just so we can see if there's any other stationary points hidden here that I might not see straight away. And for this, we're going to use the expanded version. So you get f dash x, 3x squared, plus 6x. I'm going to let f dash x equals 0, so we get 3x squared plus 6x equals 0. I'm going to factor a 3x out of this, so we get 3x multiplied by x plus 2 has to equal 0. So therefore, x can equal 0, or x can equal -2. Well, we knew there was a turning point at x equals -2, but there's also a stationary point at x equals 0. If I ignore the domain for a second, and I draw the whole graph, and I'm putting 1, 0 here, because of this term right here, we just didn't include it earlier because of the -3 to 0 domain, and I draw the whole graph, it might just look something like this. So now all we have to do is we just have to draw this graph, but from -3 to 0 only. So let's do that. So let me just get rid of these arrows as well. So if we think about it, it would go like this. Maybe we can do the shape a little bit better. Like that. Makes it clear that the tangent here has a gradient of 0, and here the tangent has a gradient of 0 as well. There we go. And we can get rid of this 1, 0. Now we can just label. And that's it. That's our graph. Thanks so much for watching.